we go. This is called trigonometric. Metric. I'm having trouble writing today.
Trigonometric?
Trigonometric.
Forgot the
Oh, there should be a no. Sorry. Let's try this. Okay.
No. Oh, no, I need to write
Trigonometric ratios. Okay? And so, just to tell you, this part of the word means what?
Three.
Okay, or triangles usually. Triangles. And in this case, metric means measured, right? And so basically trigonometry, which can involve a whole semester, a whole year course, and it applies to all levels of math up through calculus and beyond. It's all about based on measuring triangles, okay? And the ratios of the sides, okay? And so I'm not sure what the oh no means other than it's hard. So this means triangle, this means measures, and this means oh no! Okay.
Like that?
That was a pretty good. Okay, so that was Mr. Leader original. I want you to know. All right. So if I draw a triangle, which I'm going to draw, a right triangle, and how do I draw a right triangle? I want to draw it the other way. Okay. Oh, okay. There's a triangle. So, and if I say, let's just say that this angle, for instance, is 31 degrees. Okay. And this side is 3, and this side is 5. Okay. Now, if I draw another triangle that is similar to this triangle, so I'm going to try to make a copy. I'm going to try. Okay. Edit. Oh, that's not where I go. I go here. File. What did I do?
Oh, no.
See? That's what happens. So if I go, is this the one I do? I go to here. File. There must be an easier way. Edit. Didn't I hit? Oh, I must have lost that. File. Edit. Copy. And then there's no control C on this. File. Edit. Paste. Okay. And I draw another triangle that kind of looks like this triangle, but I'm going to make it bigger. Okay. Bigger. So here's another one. So let's say that instead of this, let's say that these are similar. Okay. And that this side is going to be 9, and this side is going to be 15. What does this angle have to be?
31.
This angle still has to be 31 if they're similar, right? Okay? And so what somebody figured out is that when this angle is 31 degrees, and the ratio of this side to this side are the same, right? This over this has to equal this over this. This angle is always going to be what?
The same.
It's always going to be the same, okay? And so then people discovered that I can use this. Can you take some notes? Edit, file, edit, file, edit, paste. Okay? So if I take another triangle that looks like this triangle, and I call, let's move it to up. And if I know that this angle is 31 degrees right here, and I want to, for instance, find this side over here, okay? and I know that this is 55 feet from here to here. Could I do that based on the fact that all these triangles are similar?
Yes.
Yes, right, because this has got to be a 90-degree angle, right? And if we know that this is 31 and this is 31, we had a conjecture way back when that said that by angle, these triangles are similar.
Wait, how do you know that's 90 degrees?
Well, I'm just telling you.
Okay.
Okay, so all these triangles are similar. So if these are similar, then these sides have to be proportional, right? 3 is to 5 as 9 is to 15 as x is to 55. So what I could do is I could go 9 is to 15 as x is to 55, and I can figure it out. Okay. However, that ratio is called something specific. Okay. That ratio is called the tangent ratio. And if you go on your calculator, okay, and you go tangent of 31 degrees, okay, let me just show you that. Let's see if I can do this with my calculator. So if you have a calculator, now you need to have a scientific calculator. And let's get rid of this thing. Let's get rid of that. Let's go view. Always in first. Okay. And then hopefully when I bring this up, there we go. Okay. So first thing they want to do is, probably you don't have this kind of calculator, but if you do, for most calculators, you have to make sure that you are in degree mode. Okay, most of you will be automatically set to degree mode, but in some cases might be in radian mode. And radian mode is just another way to measure angles, okay, which you'll learn about later. So now if I go tangent, you see, where's that button? See this? Tangent, and I hit 31, like that. If I hit that in my calculator, I get 0.6086. Now watch this as well. Okay, 9 divided by 15 equals about the exact same thing. See that? Okay. So what someone did, okay, is they went in a long time ago. They went in and they figured out if the ratio of this side to this side is 0.6, then that angle is 31 degrees. And vice versa. If this angle is 31 degrees, then the ratio of this side to this side is 9 over 15. And that is called the tangent ratio. And the tangent, so that comes out to be 0.60. So I could have done it like this, but I also could have done it like this. The tangent of 31 degrees is equal to x over 55. Okay? And the way you solve that is you multiply, you cross multiply, you multiply both sides by 55. See that? Yes? And you multiply this by 55, right? So if I were doing this particular problem, I would take the tangent of 31. So I go tangent of 31, and you got to close that parentheses, times 55. And I get that this side, this x is 33.04. Okay? Now, years ago, when I was a kid, we didn't really have these kind of calculators. I'm not kidding. I'm that old. And what they had in the back of the book was tables. Okay? And you have little tables, and over here you'd have like the angle. Okay? So this is like, they'd have listed like 5 degrees, 6 degrees, 7 degrees, and then they had over here, right? And someone went through and figured this all out, and then they'd have tangent, and then they'd have sine, and then they'd have cosine. And then you would look at you'd go down to 31, and you look at the table, and you'd see that value, okay? But nowadays, we have scientific calculators that do that for you, okay? So, with tangent, new piece of paper, with tangent, I'm going to keep this calculator here so we can see. So the tangent is defined as tangent So here, and this only works for right triangles, okay? So sometimes they call this A, sometimes they call this B. Usually they call the right angle C, okay? And if I'm looking at A, this side is called the opposite side. Okay, this side is called the what side? I'll give you a hint. That's the hypotenuse side, and that's always the hypotenuse, okay? And this is called the adjacent side. Okay? So adjacent means what? If you say he is adjacent to her, that means they are next to each other, okay? So the side that is next to A, which is not the hypotenuse, is called the adjacent side. The side that is directly across from A is called the opposite side. So if I'm standing at B, which is the opposite side from B?
The adjacent side.
Yeah, so that becomes that, right? Which is the adjacent side of B? If I'm standing at B, yeah, it would be BC. Okay, so it changes depending whether you're standing over here or standing over here. C, they don't usually talk about the adjacent side or opposite side to C because that's a right angle and you don't have to worry about it. So the tangent of A is defined as the ratio of the opposite side to the adjacent side. Okay? A, D, J. Okay? So the ratio of this side to this side is defined as the tangent. Okay? Then we have another one, the cosine. Or let's do the sine first. Okay? Sine, and it's S-I-N-E, but they abbreviated it S-I-N, and that's equal to the opposite side over the hypotenuse side, like that.
To find what?
So sine of angle A is defined as the ratio of this over this. Okay? You'll see as we work through this. Okay? The cosine of A is defined as the adjacent side over the hypotenuse side. Okay? And there's a way that they teach you to remember this. And it's called S-O-H, SOHCAHTOA. How many of you have heard of that before? Anyone? Okay, so you should write this down. And there's some story that they used to tell about Chief SOHCAHTOA.
Tell us.
I don't remember what the story
Look,
was.
you should look it up.
You could look it up, but it's just a way to remember this. But SOHCAHTOA, if you know how to spell it, stands for sine is equal to the opposite side over the hypotenuse side. Okay? Whoops. And hypotenuse. C, big C, means the cosine, and it's spelled like that, but usually on your calculator or in math classes they just abbreviate COS, is equal to the adjacent side over the hypotenuse side. Okay? And tangent, which they abbreviate TAN, but it's G-E-N-T. Tangent is the opposite side over the adjacent side. Okay? And that you should be able to know. Okay? So looking at this picture, what would be the cosine? Let's do the cosine of, and usually when they have a big letter, they do it like that. What's the cosine of B? If I'm standing here, what's the cosine of B? Cosine is adjacent over hypotenuse. So what sides would I be lining up if I wanted the cosine of B? Which one?
BC and BA.
Now instead of calling this opposite and adjacent, I'm going to erase these. Hypotenuse is always hypotenuse, okay? But sometimes the side opposite big C is little c. And the side opposite big B they call little b. And the side opposite big A they call little a. So who could give me an expression for the cosine of B? Where's the adjacent side to B?
A little a.
Little a. And where's the hypotenuse? C. Okay? What's the sine of B? Sine of B,
Is that the opposite?
opposite
B.
B over C. And what's the tangent of B? And the reason I write these B's kind of weird, when you get to pre-calc, they call them betas instead of B's, because with angles, a lot of times I'll name them by Greek letters. Okay? So what would be the tangent of B?
B over A.
B over A. Okay? Now if I'm standing B over A. So if I'm standing at A, that all changes. What's the cosine of angle A? What's the cosine angle?
B.
B over C. Adjacent over hypotenuse. Remember, the hypotenuse can only be the hypotenuse. What's the sine of A?
A over C.
A over C. And what's the tangent of A? Is tangent of A is opposite over adjacent equals A over B. Okay? Sorry that I'm running out of room. Okay? So now, how do you use this to solve problems? I'll show you. I'll show you this, class. New piece of paper. New triangle. Where's the triangle? And I try to not always draw the triangles exactly the same. Well, I don't want to draw it upside down like that. Let's draw this. Let's draw this triangle. So say I'm looking at this. I know this is a right angle. Okay? And I look up at this skyscraper, which I know is 410 feet above the ground. That's pretty high, right? And I want to know how far it is. So say I'm standing right here, okay, this little person, or at least my eyeball is. And I want to know how far is it from here to here, okay? Which of my three trigonometric ratios can I use? From this angle 20, what side is this? Opposite, adjacent, or hypotenuse? That's the opposite, okay? What side is this? Adjacent. So which of my three trig ratios will deal with opposite and adjacent? Tangent. So what I'm going to write is that the tangent of 20 degrees, okay, is 410 over x, okay? You see where that comes from? Opposite side over adjacent side. So now I got to get x by itself. Does anyone know how to get x by itself? Yeah, yes, you would multiply both sides by x. Okay? And then what would I do on top of that?
Divide whatever.
Divide by this, right? Tangent of 2 and 2 kind of algebraic steps at once. Multiply both sides by x and divide by tangent of 20. Okay? In that case, what happens is these x's go away, right? These tan 20s go away. What I get is that x is equal to 410 divided by the tangent of 20. Okay? And now to plug that into your calculator, watch. And different calculators work different ways, but most of them work this way. You go 4, let's clear first. Okay? Clear. So I'm going to go 410 divided by, and sometimes you have to put this in parentheses, but I don't think you have to in this case. Tangent. On some calculators, you have to do 20 and then tangent, which can be a little bit confusing. So this 410 divided by the tangent of 20, and I get 1,126 feet. So this distance from here is 1,126.4 feet. Okay? If that's in feet. So again, what someone did, or what people figured out, is that when this angle is 20 degrees, the ratio of this side to this side is something specific. And that's what you're finding when you're finding tangent of 20. You're finding the ratio of this over this, okay? But just so you know, all of these things are just ratios. Okay? Yes? No? We're going to do another one, okay? And so that's kind of, the other thing, if you notice, if I have one where the x is on the bottom, all I really have to do is switch places with the, I'm basically multiplying both sides by x and dividing by both sides by tan of 20. But algebraically, what I could legally do is just flip-flop this and this to solve for x, okay? For instance, if I started with, just for instance, say I have tangent of 36 equals 50 over x. Rather than going through all this algebra, I could just rewrite this as x equals 50 over tan of 36, okay? I could just switch places with these two things. Because really what I'm doing is multiplying both sides by x and dividing both sides by tan of 36. So let's do an ocho problem. An ocho? Is that a word? Sure, whatever you say. So let's do a right triangle that's and again, this only works for right triangles. So it doesn't work for non-right triangles. So I'm going to kind of flip this. Let's see if I can grab it and twist it, do something weird with it. Can I turn this? Yes. Whoa. So now my right triangle looks kind of like this, okay? With this angle being the right angle up here. That's not a very good right. Let's make this the right angle, okay? And let's make this side 8 and this side 12. And now we're going to go backwards, okay? Let's do another one. Now let's do this first. And they say find angle B. And in angle B they're talking about this, okay? So this is a little bit different. At angle B, which side is this?
Hypotenuse.
This is the hypotenuse side, right? At angle B, which side does this have to be?
Adjacent.
Adjacent side, ADJ. ADJ. Okay? So which of my three ratios uses adjacent and hypotenuse?
Cosine.
Cosine. So I know that the cosine of B equals 8 adjacent over hypotenuse 8 over 12. Okay? Now, what they're asking you is finding that angle. So when this side is 8 and that side is 12, what is that angle? So if you look on your calculator, most calculators, what that means is you use this button, okay? 8 over 12. On your calculator equals B. This is called the inverse cosine, okay? And what this says, it says what angle has a cosine ratio of 8 to 12. Unfortunately, someone plugged this into all your calculators and figured it out. And usually that's found right above the cosine button. So if you hit second, and then I go cosine, okay, see how the -1 comes up? Okay? That's called the inverse cosine, and now I go 8 divided by 12, okay? And I get, boom, 48.18 degrees. So that angle right there would be 48.18 degrees, okay? So that's how you use trig to find angle. So given two sides, and it's a right angle, you can find, you need to have two things, okay? You need to have either two sides to find an angle, or you can have a side and an angle to find another side. Let's do one more, okay? So say I have another triangle. Where's my other triangle? Here we go. Let's see what's going to happen. Why is it always drawing it upside down? All right, so no crunchies in class. There we go. Oh. Okay, I'm going to select it and move it and drag it. Move it here. No whistling in class, against the rules. Who's whistling?
He time.
V
Oh,
tie.
no.
Okay. So,
So you're crunching.
say you have this tree right here.
That's not possible.
So,
It was Lily.
this is kind of what we'll do outside. Say you want to know this, okay? And you know this distance over here, I don't know how, but say you know that this is 100 feet. You put a cable up to a tree, okay? And then you use your little angle measuring device, which we're going to do outside on clock day. And you measure this angle to be, I don't know, 40, oh yeah, next week we're going to 40 degrees, okay? And I want to find out how tall is this, let's call it a building. Here's the building, and you have to save the lady on the top of the burning building, okay? Okay, so she's up here, okay? Okay. Help me. Help me. So this, this is your fire truck, okay? There's a fire truck, and here's you measure using your angle measuring device. Your ladder, is 100 feet long. That's pretty long for a ladder. And you want to know how high is the building because you want to tell the lady whether to jump or not, okay? or whether she can bounce off the.
Why would you tell her that? You have a ladder.
You're gonna- Oh yeah, that's a good one. So anyway, say you want to know how tall the building. So which trig ratio should I use if I have this side and this side?
The
From here, this is the what side?
Cosine.
No.
sin. What is that?
Yeah.
Opposite.
This is the opposite side, and this is the
Hypotenuse.
hypotenuse. So which one uses opposite
Sine.
hypotenuse? Which?
Sin A.
Sine of 40 degrees. That should say sine. So sine of 40, okay, 40 degrees equals opposite x over 100, okay? So this is real simple. You just multiply both sides by 100, right? And you get that, this crosses out, and you get x equals 100 times the sine of 40. And you know what? It's better to plug it all into your, first solve for x, and then plug it all into your calculator in one chunk. Because otherwise you're going to round off things and you're going to get messed up errors. So I'm going to do that over here. I'm going to go 100. And you don't need a graphing calculator. Most scientific calculators have sine and cosine, okay? 100, and you don't really need to hit a time sign because it assumes that you're multiplying. 100 sine of 40, okay? And you hit enter. And so this lady, this distance here is 64.27. So probably she doesn't want to jump. That would hurt a whole lot. Okay? So that's how you do it. Okay? So your homework is homework.
No homework.
Page 6. And this again isn't due till Friday. 624. 1 through 22. But a lot of it is just say what the sign. You don't have to do 22 problems like this. Okay? 6 all. Some of it is just,
We don't have homework.
write the ratio, push this button on your calculator. Homework tonight, just to work on your project. If you want to get started on this, you can start on that. That's about it.